In this video, we will introduce you to the DEM-CFD coupling topic using Ansys Rocky and Ansys Fluent. In engineering simulations, the discrete element method, or DEM, is a powerful tool widely used to model and analyze the behavior of granular materials and particle interactions. From understanding the flow of materials in industrial processes to predicting wear in equipment, DEM provides a detailed particle-level perspective that is invaluable for engineers. However, there are many scenarios where a DEM-only simulation cannot capture all the physical phenomena occurring. When particles interact with a fluid, such as in sediment transport or slurry flows, the fluid's behavior significantly influences the dynamics of the particles and vice versa. In such cases, coupling DEM with computational fluid dynamics CFD models provides a deeper understanding of these processes, making this coupling a key tool for solving many real-world engineering problems. Here are some practical examples of DEM-CFD coupled simulations. In the modeling of a vacuum cleaner, debris is represented as particles which are suctioned by the airflow. As the air moves through the vacuum, particles are carried along, colliding with the walls, the filter, and other particles before settling in the collection chamber. In the modeling of a mixing tank, an impeller generates fluid flow. When particles are introduced, they interact with the fluid and each other. Some may remain suspended, while others settle depending on their size, density, and fluid forces. This map displays all DEM-CFD coupling options available in Ansys Rocky software. For the purpose of this lesson, we are focusing on the unresolved and semi-resolved options, which are couplings that require the Ansys Fluent software. The unresolved method does not resolve the fluid flow around particles. It approximates the interactions between fluid and particles using averaged models and empirical relationships. The one-way Fluent covers steady state and transient flows. This will vary according to the case you set up in Ansys Fluent. It is recommended for dilute flows, meaning a lower concentration of particles in the fluid. The fluid flow affects particles, and not the other way around. Ansys Fluent software is required for solving and exporting the flow field. The two-way Fluent coupling mode is recommended for dense flows, meaning there is a higher concentration of particles in the fluid. Particles are small compared to the CFD cell size, and particles will also affect the fluid flow by exchanging energy and momentum. Unlike the unresolved approach, the semi-resolved method partially captures the flow around particles, providing more accurate fluid-particle interactions. Nonetheless, it is a more computationally demanding method. The semi-resolved method is also recommended for dense flows. Particles are large compared to the CFD cell size. Particles will affect the flow by exchanging energy and momentum. In this lesson, we will demonstrate a CFD-DEM two-way coupling case using Ansys Rocky software and Ansys Fluent software. The case demonstrated is the fluidized bed, which is Rocky's tutorial 14. You can access the tutorial 14 from the links available in this lesson. The fluidized bed consists of a bed of hot particles being fluidized by a current of colder air. This is a common application in the chemical industry, due to enhanced mixing and improved heat and mass transfer between fluid and particles. Since the purpose of this lesson is to demonstrate how to use Rocky and CFD coupled simulations, we are going to use an already prepared CFD case to be coupled with Ansys Rocky software. A single-phase, air CFD case with heat transfer is set up in Ansys Fluent. The case is saved for later two-way coupling. For the Ansys Rocky part of the setup in this tutorial, the project starts by defining the physics and the material properties. Next, the geometry components are imported from a .cas file exported from Fluent. After that, two types of particles are created, and then the parameters for creating a volumetric inlet are defined. When the setup is done, the simulation is ready to run. This project is saved for restart and will be used for the coupled simulation. Finally, the CFD case is imported in the two-way coupling mode option available in Ansys Rocky. After setting the parameters, the simulation is run again. After the simulation is finished processing, here are some post-processing examples of a DEM-CFD coupled simulation. It's possible to analyze the mixing of particles due to airflow, to analyze variations in temperature for both particles and fluid, or even to visualize fluid velocity and how this property varies along the simulation. Be sure to watch the other 3 videos in this couplings course. By integrating Ansys Rocky with other powerful Ansys software, you can make the most of multi-physics simulations.